Hello and Assalamu alaikum. My name is Jama Muhammad Abdullahi and I'm from Group 9 and I'm going to explain slide 4 MEMS thermal sensor. The resistance of the metal is described as this formula. If the temperature of the RTD varies linearly, then the relationship between the measured resistance and the temperature change can be described as this formula, where RT is the resistance at a certain temperature, RO is the resistance at the 0 degrees Celsius, alpha is the resistance change factor per degree Celsius change of the temperature, T is the temperature to be measured, and TO is the initial temperature. From this pictures here, you can see that this is the 3D view of the analysis voltage simulation, and this one is the top view of the analysis voltage simulation. That's all, and thank you to everyone.
Hi and Assalamualaikum. My name is Muhammad Wafi. So I'm going to explain about the layout design of our thermal sensor. So here is the top view of our MEMS Pro simulation. It, there is a label part with their own dimension here. Here that is how we make our MEMS Pro design. And here is the material database for each of the material that we use in the thermal sensor with their own property, which is already fixed. And that's it about the layout that we did in MEMS Pro design. Next is the process definition and 3D model. So here the first one is the substrate wafer, where there is only silicon substrate. Second is that we put a layer of silicon dioxide, where the second one is the substrate electrode deposition. The third one is where we put the molybdenum layer before the etching process. The third one is the lower electrode deposition. The fourth one is the lower electrode etch, where we get the shape of our metal on the top of the silicon dioxide. Here is the final cross section. You can see here there is three layers, where the top one is molybdenum, the middle one is the silicon dioxide, and the third one, the below, is the silicon substrate. And that's it for me about our thermal sensor design MEMS MEMS uh, MEMS simulation. Thank you very much.
Assalamualaikum, I'm Adam bin Mat Salim. Now I will present our MEMS finite element analysis. First, in analysis system, we insert the material and property data inside the engineering data. The material we use is molybdenum, silicon dioxide, and silicon. The property we use is density, isotropic elasticity, isotropic thermal conductivity, and isotropic resistivity that can be found in static structure properties and thermal electric properties. Second, we draw the geometry inside the design modular and label the annotation using geometry space claim. Third, we model the geometry to determine layer material and create a mesh so that the solution view will be smooth. Next, we set up the input and boundary condition, which is 22 to 100 degrees Celsius for temperature and voltage value from 0 to 1 volt. So here is our NC solution and result. From the left, the image shows the electric voltage solution, and next to it is temperature solution. The first graph is voltage vs temperature when different size of molybdenum applied. Sensing material with longer size will have higher voltage at lower temperature. Second graph shows the voltage vs temperature when different thickness applied. Molybdenum with higher thickness will have higher voltage at higher temperature. Third graph shows the voltage vs temperature when different distance between molybdenum turn applied. Turn with the higher distance will have higher voltage at lower temperature. The fourth graph shows the voltage vs temperature when changing different material. Metal with higher resistivity will have higher voltage at lower temperature.
A very good morning to Sir Hafiz. So I am Low Ching Shen. I'm going to present for MEMS thermal sensor for campus sustainability. So for our title, we are going to do it as a generating alarm through over temperature by fan on. So the requirement temperature is set using temperature setting device like potentiometer. The temperature sensor actual temperature, the controlling device like microcontroller take both this temperature as input and display them on the display device. It compares actual temperature with set temperature. If actual temperature is higher or lower, then requires set temperature, then it gives signal to temperature controlling device to increase or decrease the temperature. And thus it tries to maintain the temperature within required limit. For example, the temperature controlling device is cooler, compressor, and it is required to maintain cooling. In this system, as the actual sense temperature increase above certain limit over set temperature, the cooling is increased using cooler, compressor, and vice versa. Along with all these devices, most of the temperature control system has visual indicator like bulb LED for over under temperature and sound alarm for the audio alert. So for the United Nations Sustainability Development Goals, the temperature management is a global environmental challenge. Drastically increase of temperature will increase numerous environmental issues such as greenhouse effect, air pollution, and health problems. So, generating alarms through over temperature by fan-ons is proposed by utilizing a MEMS thermal sensor. This solution will create high efficiency in terms of resources and cost associated with help in reducing temperature in closed area. The proposed system is used for monitoring over temperature and generates an alarm using a temperature sensor. This system is set to the highest limit of the temperature control point. When the temperature increases the fixed temperature, then it generates the sound to give an alert to the user for his attention.